In the previous video, we talked about the components of a hemocytometer and what it's used for. In this video, we're going to count the number of red blood cells in a sample of human blood using the hemocytometer. You may use blood from any animal to count the RBC population. For this experiment, you will need the following: counting chamber, RBC pipette, blood sample either from a pricked finger or from a sample drawn from the vein and stored in a tube containing an anticoagulant, RBC diluting solution, compound light microscope, cotton and rubbing alcohol. Take the RBC pipette pre-cleaned with alcohol. Draw the blood sample till the 0.5 mark using your mouth or a syringe, while taking care to avoid any air bubbles from entering the pipette. This step requires a bit of patience and practice. If you happen to suck the blood beyond 0.5 mark, you can either use a clean filter paper to carefully blot out excess blood from the pipette tip, or carefully blow out excess blood using a syringe until it reaches down to the 0.5 mark. Once that's done, carefully clean the excess blood sticking to the outer sides of the tip of the pipette using a cotton soaked in alcohol. Now carefully draw the RBC diluting solution up to the 101 mark on the pipette. Hold the pipette in a horizontal position and rotate the pipette several times in such a way that the tiny bead inside the bulb of the pipette mixes the blood and the diluting solutions thoroughly. Once thorough mixing has been accomplished, the blood sample now has a 200 times dilution. Once this is done, prepare the counting chamber for sample loading. Take the counting chamber and the cover slip, both pre-cleaned with alcohol. Carefully position the cover glass on top of the support platforms located on both sides of the counting chamber platforms. Discard the first few drops from the RBC pipette. Carefully position the tip of the pipette on one edge of the cover glass. Allow the contents of the pipette to gradually flow into the narrow space between the cover glass and the counting chamber via a capillary force like you see here. You may load the other counting chamber as well in a similar fashion. Once you're done loading the chambers, keep aside the counting chamber for a few minutes to allow the RBCs to settle. The slide is now ready for microscopic observation. First, locate the small square at the center of the counting grid under low power of the microscope. You may refer to my previous videos on hemocytometer to see which of the squares in the counting chamber are to be used for RBC counting. You may also need to adjust the light intensity of the microscope in order to visualize the fine lines in the counting grid. Once you've located the RBC counting squares, switch to 10x then to 40x objective to begin the counting. Locate the 1st, 5th, 13th, 21st, and 25th smaller squares in the RBC grid. Applying the margin rule or L rule of cell counting, count the RBCs lying inside of these squares and those lying on the borders of the lower and left side of each square. Do not count those cells lying on the borders of the upper and right sides of the squares. This is how RBCs will appear on the counting grids under 10x. And here's RBCs under 40x as seen in one of the 5 smaller squares to be used for RBC counting. Remember the margin rule and count the cells in each square accordingly. Once you've counted the number of cells in the 5 smaller squares, aka the 80 smallest squares, all you have to do is to just add them up and multiply the sum by a factor of 10,000. This gives you the total RBC count per cubic millimeter of blood sample. Or if you want to do the math, you can use this formula to come up with the number of RBCs in 1 cubic millimeter of the blood sample. RBC count equals the number of cells counted into dilution factor into depth factor divided by area counted. We know that dilution of the blood sample is 1 in 200, so dilution factor is 200. Depth or height of the blood film is 1/10 of a millimeter. Therefore, depth factor is 10. Area counted is 80 by 400 smallest squares, which equals 1/5 of a square millimeter. Assuming that the number of cells counted is n, and using the above known data, the total RBC count per cubic millimeter of blood equals n into 200 into 10 divided by 1/5, which equals n into 10,000. Normal RBC count for adult men and women is as follows. In men, it's 4.7 to 6.1 million cells per cubic millimeter. In women, it's 4.2 to 5.4 million cells per cubic millimeter. A low RBC count, also called erythropenia, could indicate anemia, vitamin B deficiency, internal bleeding, kidney diseases, malnutrition, etc. A high RBC count, also called polycythemia, could be caused by smoking, congenital heart diseases, dehydration, hypoxia, and certain lung diseases, etc. For counting of total platelet cells in a cubic millimeter of blood, the same procedure and formula applies as in RBC counting. The only difference is that the diluting solution to be used in case of platelet count is a 1% solution of ammonium oxalate prepared by dissolving 1 gram of ammonium oxalate in 100 ml of distilled water. If platelet count is extremely low, use the WBC pipette and follow the procedure and formula for a WBC count using 1% ammonium oxalate as diluting solution. A normal platelet count ranges from 140,000 to 450,000 cells per cubic millimeter. A low platelet count, also known as thrombocytopenia, may be caused by leukemia and certain other cancers, certain types of anemia, certain viral infections, certain respiratory disorders, radio and chemotherapy, sepsis, certain autoimmune disorders, certain medications and drugs, exposure to toxic substances, alcoholism, cirrhosis, iron and folate deficiency, vitamin B12 deficiency, etc. A high platelet count, also known as thrombocytosis, may be caused by bleeding, cancer, certain infections, iron deficiency, removal of spleen, certain types of anemia, certain inflammatory diseases, surgery, etc.